All right. All right, so we're officially recording. Today is April the 7th, Monday. This is the announcement from last week. A couple things I want to discuss. I don't want to yell, but I want to be close to these folks. That's why I don't bring in my little clicker so I don't wander off and I stay close to the computer for the people here. But last week, I look forward to the homeworks. I saw a couple of them. I really like them because you're using your originality and data and all that other kind of good stuff, creativity to do stuff instead of just me telling you what to do. Because no one wants to be told what to do. You want to do it, you want to do it yourself. Also, if you presented at GERS, make sure you post everything in this folder here. I still see a couple things missing, and I want to make sure we get them submitted and all that other good stuff, because at the end of the semester, when I start replacing grades with 100% and yours isn't there, I don't want to argue with people like I submitted it, I presented. No, I just don't see it here. And so just make sure you post something in there. I'm big on Google Drive these days because OneDrive, you need NCCU, and I want other people to access it, and I kind of just trust people not to go and delete and edit and all that other good stuff, okay? This week, we're going to work on something called data cleaning. We've got a nice little Python exercise attached to it. So we're going to I'm going to give you the Python code. We're going to go and edit it a little bit. And it's an exercise that I've used, and we're going to look at something that I got paid like $78,000 to do with the NCDOT. So this is like real life stuff that we can do, real life stuff that we can do. And one other thing here, I discussed the field mapping class. That's May 5th to May 16th. It'll be 9 days because we're not going to meet on the 9th, which is the NCCU graduation. So we're going to meet for 4 days on the week of May 5th. We're going to have a field trip to Occoneechee Mountain State Park over in Hillsborough. We're going to go do some GPS. We're going to go, I'm trying to get permission to go to a cemetery and use my drone and my GPR. And we're going to go field day. And then we're just going to basically play with the data the rest of the time and present. And that is and there's 5 exercises attached to it. But that is the field mapping class. Please register for it, because if not enough people register, it gets dropped. And then, like I said before, Dr. McGinn and I will entice people to register. So if you're on my roster by April 21st, I can send the request to get it reimbursed, because that's how long it takes for everything to get reimbursed. So also, if you took this class as like a 49.50 and you want credit for 50/50, did you do that?
I took it last year
as an undergrad.
Okay, so if you want grad credit for it, you can do that. So we can get you ABM, you get grad credit for it. I pay, and I pay $700, and you get grad credit for it. So if you do your master's here, cool. If you don't do your master's here, you got the AAC 50/50 on your transcript.
Okay.
Okay, so we can do that if you want. You can talk to Dr. McGinn, like, hey, just sign me up for field mapping. We'll just apply the grade that was earned last summer into that. And if you want to do the field trip with us this year, you're more than welcome to join us. But I'm not under no obligation to do so.
Gotcha.
Okay, but I will post, we will post the money for that. And then this is the schedule for the rest of the semester. So today we're going to talk about data cleaning. Next week, we're going to talk about metadata. Daniel, Andy, who's joining us online. Lots of people out there, metadata, that's really important these days, especially with the whole idea of open science, meaning, I want to download stuff. What the heck am I downloading? What's it mean? Where's it from? So metadata is really an expansion of some of the tags that you entered for open science format. Next, this is the first time I've done this, but a lecture and exercise on deep learning. And so I'm starting to learn about some of the deep learning tools in ArcGIS Pro, where I had a student named Baron go and collect cars, collect pictures of the parking lot, images of the parking lot, and then we are going to use some deep learning models to pick out all the cars, which I think is kind of neat. Because eventually what I would do, I was just talking to someone over in math and physics about them looking at models to detect wildfires. Because, you live out in this great expanses in, Canada and all these, Canada and Western United States, not a lot of people there to detect possible wildfires using real-time or almost real-time imagery. And so, hey, this is a potential wildfire. We better go take care of this, from, imagery that's getting processed, almost in real time because, these things are new and relatively new. And so I think this is pretty neat. We've got NASA learning modules, and then we'll discuss the final because in 3 weeks from today, we will have the final exam for those people who didn't present at GERS. And then we'll have all late and outstanding work due, and then the final projects will be due. This is a big week for us. We got the North Carolina Space Symposium. 14 of us are going over to the North Carolina Space Symposium in Raleigh on Friday. And that's in conjunction with a visit from NASA. So people from Marshall Space Center, who are the natural hazards team, are coming up from Marshall Space Center. A couple of them will be joining us virtually to basically see all the stuff that we're doing here. So see all the stuff we're doing here. So we're gonna kind of talk about some of the faculty stuff, and in the afternoon, we're gonna focus on the students, and then some of those students will be presenting at NASA Space, the NASA North Carolina Space Grants. Whatever, North Carolina, whatever it is. What's it called again? That thing. He just said NC Space Symposium. I throw NASA in there. I go home, when I say NASA to my wife, she just gets so impressed and all the people and like, you work for NASA? I was like, no, I don't. They gave me a little money but they were really impressed by it. And so my mom goes and tells everyone. That's another thing. Okay, but all kidding aside, they're going to be here. So, I'm not going to be on campus Wednesday. I've got, my kids have some medical stuff that we got to deal with. And so, those of you who need posters done or anything, latest I want you printing those out is tomorrow. And then I've sent those students kind of directives. So, but it's going to be in 2229. So if anyone wants to come by, check it out on Thursday. Conference room 2229, come introduce your students, because basically this class that you're taking was created from that NASA grant to help facilitate data science and data science training. So if I think of it, I'll post an announcement about going. I think our administrative assistant has kind of facilitated some snacks. So I'm a big snack person. So feel free to stop by, especially in the afternoon when there are going to be some student presentations and some of the things that you've done. And it's been a pretty good, and basically we want money for the rest of the grant, so they want to see that proper progress is being done, and it's really impacting the students. They like me, they're nice to me, but they want to see how it's impacted you all and how the generous gifts and generous grants that they've given, they're not really gifts, but the generous grants that they've given us really have some return and impact on our students, both here and then off campus. So that's about it with this. So what we're going to talk about today, and this is exercise number 8, it's called data cleaning. And we're going to look at something called, and I'm going to revisit this here in a little bit, but these are LRS ARCs. It's called like line route systems. And if you go to like the NCDOT webpage, you can go and download feature databases of every single ARC in the state, and there's like 1.2 million, 1.107 individual ARCs. So this is a line feature class of 1.7 million ARCs. Okay, and they call them ARCs, but they're really lines, and we know what lines are. They don't have any width, but they have multiple vertices. We don't really explore those vertices too much, and each of these have properties, because I'm going to talk about the project that I did for the NCDOT on this, where we did some data cleaning and data integrity, and you can maybe think of some Python programming solutions so we can make this nice and neat. But this is what it looks like. Now, these are road characteristics. So road characteristics mean things like speed limit, number of lanes, turn, if it has a turn lane, yes or no. Does it have a median? What's the median width? So whenever one of those characteristics change, there's a separate ARC for these. So the number of routes and roads is different than this. It's a lot less than this, because we have like Interstate 40 that runs, east, west from Wilmington all the way out to Tennessee. And that's just literally like one feature on the map, but it's probably composed of a couple hundred different arcs where the speed limit changes, the number of lanes change. And whenever that changes, it gets a brand new LRS arc that can be linked to a route name. So it can be linked back to a route name. And it gets a little goofy at times because you drive 4085. Is it Route 40? Is it Route 85 between Hillsborough and Greensboro? I don't know which one it is. And so they have these different route names and things like that. So we've got these road characteristics we're going to talk about because we're going to look at the spatial integrity of databases because we're going to say, hey, what should the speed limits be? And we're going to just look at one little thing here. Like, what should the speed limit be? Should the speed limit be negative? No. Now, I could go do a find and replace or calculate new columns, but since we're kind of doing Python, we should probably think of some elegant programming solutions to say, hey, if it's negative, change it to something else. And even more elegant programming solutions like, hey, if it's negative, let's look at the route class. And if the route class is an interstate, we'll change that speed limit to 65. If it's a US route, we'll change it to something else or whatever. And so I'm kind of just thinking of neat ways that we can programmatically do this besides what we call brute force. Brute force is just looking at it by hand and just doing some select by locations, anything less than 0. You could do that. It might even take less time to do it on this database, but next time it comes out, the third quarter and the fourth quarter and the first quarter of next year, these data come out and you have to find and replace it again. Well, you already have a Python programming solution that does that for you already. So I'm going to talk a little bit. And what I did was I took a subset of the subset. And so when we look at these, and this is what some of your NCDOT data has here. It's got like highway exits right here. So we've got a feature class of highway exits. There's things out there on like deer vehicle collisions that I've looked at in the past. There's probably something with vehicle crashes. So like there's a whole spatial analysis component with transportation, vehicle crashes. There's a whole psychological component, but there's a whole, I was at a conference recently where we were looking at pedestrian accidents in Hartford because most of like the accidents that occur on the roads, like the highest percentage of them is with motorcycles, actually, motorcycles and bikes. Like car accidents account for a really small proportion of accidents. It was something like 16%, bikes were more, pedestrians were more, and then motorcycles were a lot. I guess you don't see motorcycles, but they're still traveling at a high rate of speed. And so these motor vehicle collisions, motor vehicles hitting motor vehicles really doesn't make up a lot, even though you see these things on the roads all the time and not as many bikes and motorcycles and people who account for more of these. But there's databases out there. And if you're really slick, you could probably turn some of the records that exist from the NCDOT into, turn these from the NCDOT into feature classes that look like this that you can analyze. The one thing I will mention before, because I was looking at Daniel here, that he was looking at traffic volume versus air quality. Also, we have something called AADT data through the NCDOT. That's average annual daily traffic. And so we've got probably 40 or 50 points throughout Durham. And if I think of it at the break, I'll upload these that have those like little rubber strips that go across the road that you drive over, those. And it's got the average annual daily traffic for each of those throughout different years. So you might have them for 2017, 2019, 2021, 2023 to see if there's a relationship between how much of a relationship there is between traffic and air quality. You got those little strips, you got Interstate 40, but the traffic volume is going to be much different in different places. And how does that going to impact, or is that going to be a major player with air quality? Or what else? Is it population density? Is it farming? Is it other anthropogenic processes or natural processes as well? So these are just highway exits, which I thought were kind of neat. So you can see some of the highway exits here. But if I think of it, I'll get the AADT stuff up there and you can click on it because those kind of lead to some really interesting problems because the big future, with GIS. Now we got the AI, we got the ML, we got the drones and everything, but to me, topics that are things that you want to do in GIS, where is the GIS world going these days? One of the big things is transportation. Transportation planning. This week, it actually starts today, is a big conference called GIST, GIS and Transportation. It's in Portland, Oregon this year. I've been to it a couple times when it was in Little Rock. Believe it or not, Little Rock's like a really pretty city. I don't know if anyone's been there before. I like it. I like the little jogging trail downtown, and I like the library, Clinton Library. It's real nice.
It is actually.
Like it's like you think of Arkansas and you don't think of Little Rock. Yeah. And I've been to it at Charleston. There's not another nice little town, but it's in Portland this year, but it's GIST, and that's worldwide, but applications with transportation, applications with business. Where are we going to build the next, whatever, that person who dropped off your little Google thing, dropped off your little, Google package that not Google package, the Amazon package that I get 5 of a day, it seems like. How did they just put in a bunch of addresses and figure out how to get there? We use GIS. We do use vehicle routing problems and everything else. And then when I was at the NCGI's conference a few weeks ago, I met someone who works for the Raleigh school system. All he does is redistricting kindergarten bus routes. He spends his whole year just putting together all the redistricting stuff, because over in Raleigh, Wake County, they're always building new schools. So they're going to have to change the outlines of the school districts, and people are going to get really, really mad about that. Really mad. You're not going to this school. You guys have that a lot over in Wake County, don't you? Your dad still teaches there, right?
He teaches in Durham.
Durham teaches in Durham. So we got a lot of those challenges there, but who are the new kindergartners next year? Where do they live? What are the bus routes going to be? So those same applications. And so we got business, we got schools, we've got transportation, and really emerging fields, or presently big fields with GIS. And of course, utilities, sewer. We got students who work utilities, sewer, parcels, all on the backbone of GIS. But that's kind of my transportation, because transportation planning, we got 2 former students who work for the photogrammetry office over at the NCDOT right now, doing great things. All right, so enough of my tirade here. I'll get back onto it in a little bit, but a couple things about data quality, and then I'll talk about the project that we did, where I got money to do stuff with data quality, and then we'll have a break. And then we'll start looking at the program a little bit. So when we talk about GIS data quality, the big thing is garbage in, garbage out. Has anyone heard that term? You work with bad data, then basically any processing you do, it is going to be really bad. So that data quality is really poor. So if I'm making a half-mile buffer around a school, and the school really isn't where it is, it's off from the imagery, then guess what? You're just making a half-mile buffer around a point that, not the school, but the incorrect representation of it. Okay, so it's really important. There's some other quotes here, fast is fine, but accurate is everything. We'll talk about some of the differences on these things, but bad data drives out the good. And then next week, with stuff with metadata is really important, because when I worked for the military, we had lots of good GIS data. They were saved as something called, we think it was good, but we had all these places in Texas, Fort Bliss, Texas, Camp Santiago in Puerto Rico, Camp Smith, these tiny military bases that don't have the funding for their own GIS person. So basically we were the GIS person, and we'd come out every couple of years and make their maps for them with brand new data and go do some analysis. Hey, we need a new training site here. Can you make a map of it and GPS it? But sometimes the people from the Pentagon would call like, hey, this data from Fort Bliss, how old is it? And what 3 words don't they want to hear? I don't know, and this is where it leads into metadata, because I don't know, because the people didn't populate the metadata. And so what we're talking about this week, kind of, even though on the surface doesn't sound like they relate to each other, but data quality, because there's definite placeholders in metadata to quantify, quantitatively quantify, as well as qualitatively record metadata and the extent or data quality. When did you collect the data? How often is it? What are the data standards used to collect those? And hopefully I'll talk a little bit about these. And then we're going to look at the project with the NCDOT, which I really liked. And I'll talk about it in a little bit, because I think some of you in the professional field are going to run into this quandary, and you just got to get lucky once or twice here. Okay, but how do we measure it? These days with hubs and analytics, I'm always having people, hey, I want, how many times was it downloaded? How many times did people look at it? That's the important thing. This is what runs social media. Who's at the top of your, feed or whatever it's called? It's the people who get the most clicks, which is basically exacerbated by visibility. So data quality, how good is your data? Some of the things, and back in the day when I worked for the military, and I'm kind of left there 18 years ago, but what is the important thing? How do we measure quality? What scale was it created? I can digitize, literally trace it off the map. If I trace it really zoomed in versus really zoomed out, I'm gonna get two different results. And in 4010, we talked about digitizing. Remember digitizing, where we traced out the outlines of all the buildings on campus using the imagery, because there's probably not a GIS data layer just laying out there of all the NCCU buildings. Who needs it? Really, they need the campus. I want all the buildings with certain attributes that we can go and collect. We've got precision and resolution. We'll talk about the difference between those. The accuracy, how far off is it? What's the lineage? How'd you create it? Hey, on April 7th, 2025, David went and digitized these at a scale of 1 to 1,000. Because the one thing we did with the buildings feature class was it was like 10 years old. If we had a buildings feature class of NCCU from 10 years ago versus now, these are going to look entirely different. So we've got lineage, which ties into currency. What's the temporal accuracy of these? And then these are going to be recorded in metadata, which is a formalized way to store information about the information. Now, I've got Daniel and Andy and other people creating metadata for me. Information about the information. And they're really good at it. And then what are some of the standards here? And so I just submitted a grant. It's due April the 9th to give me or give some people lots of money so that we can look at standards. What standards do we have here for metadata and all these other things? Now, what's a standard? How do we go about doing things? The data itself, accuracy. Look at all these big fancy things here. FGDC, Federal Geographic Data Committee. And Standard for Digital Geospatial Metadata, ISO, International Standards Organization. Okay, these are the different ways that we can store data. And so when I worked with the military, we actually created our own standards. Hey, if I'm going to go out and GPS something, it better have an accuracy of at least 2 meters. So I'm not going to go out and GPS with my phone. My phone will get me down to, I don't know, 15, 20 feet. I've got a GPS over there that'll get me down to about 1 meter. It's pretty good. And then I can get like sub-meter surveying stuff, but that costs a little bit more. Spatial data transfer, these are kind of falling out, but we created our own standards. Like when I digitize, it's going to be at a maximum scale or minimum scale of 1 to 1,000. So if I'm looking at the outlines of buildings, it better be at 1 to 1,000. If I zoom out enough, I'm just going to be really haphazard and not really notice the outlines of these. So those are going to be really important. Now, who sets standards? Lots of people do. The one good thing about state of North Carolina, and you might have heard this before, state of North Carolina is at the forefront of standards and GIS and geospatial data. And did I show it last week? But there's a big group, we have a North Carolina GIS conference every other year, all GIS professionals across the state. Every year we have something called NCR, ARC Users Group, where they sit down and talk about the standards, particular for Esri. And actually, in May, they're going to have a free GI drone workshop. And if I think of it, I post it because did I talk about those scholarships they've had before? The NCR scholarships? Yes, kind of. I'll mention those after the break because those are important because you get scholarships and you present at North Carolina ARC Users Group to me, and it's out in Asheville this year. So my wife's like, yes, go. So I can go too. I was like, well, just leave the kids and they can fend for themselves. So when we talk about standards, what are going to be acceptable standards? Because those of us who've looked at census data, you notice that there's imputation or margins of error attached to those. And so those things can be cataloged. And these days, when we go in GPS, if you take field mapping class and you go in GPS something, it's going to have the error attached to it. Basically all the satellites up there that it's capturing, it looks like, the error that it's going to be off. 2 meters, 1 meter. And the GPS unit that I bought is actually pretty good. It just connects to my phone using Bluetooth. So I just walk around on it and I open up my field maps right here and I can just point, or field collector or whatever it is, because they're always changing names and I'm old enough that I'm still on the old name right here. Why are standards so important? We've got Baltimore Fire, Fall River Fire, where we have standardized differences in coupling hoses, hydrants, all these other things, incompatibility between GIS data sets, communication systems, all these. Even now we have, ISO standards for lots of things. I put a credit card, I go to South America or I go anywhere and I put a credit card into the machine and it like magically fits. Well, why does it fit? They probably want their own credit card sizes, right? Because there are ISO standards attached to all these as well. Okay, so things like railroad gauges and things like that, which I think is interesting. Now we have the idea of accuracy, the degree to which information corresponds to true or accepted value. So when you take an exam in this class or any class, basically I'm just measuring your accuracy. What is your answer versus what I say is the right answer? That's all we do. And so there's lots of different forms of accuracy, horizontal accuracy, how far off they are. We'll talk about that in my next lecture here. Vertical accuracy, attribute accuracy, conceptual accuracy, logical accuracy, or we use the term logical consistency because we see these things rear their ugly heads from time to time. Now, what's the problem with this? I was driving up in Virginia, driving home from north of Danville to my home in Greensboro. What's the problem with this map? What's the
You got 42 miles to go in 22 minutes?
Oh, you remember this one, Greg. Good. So look at this. It says 42 miles, 22 minutes. Like, I'm gonna have to drive at about 110
Running
miles
about
an hour.
200, run about 200, I guess.
Yeah, I'm gonna have to drive really fast. Why? Why is it like this? Because those attributes that we were looking at on that raw data set, they say speed limit 30, 30, 30, 30. What if some intern actually types in a extra zero and that section of road is speed limit 300? What's that gonna do to the time you drive on that section of road? Make it go down. So we see these issues of data accuracy all of the time. Here's another issue of data accuracy. Just driving along, nothing. There's no road here. And so different databases get updated. And so this is one that I thought was interesting where I live over in Greensboro and they had recently built a new Interstate 73 that kind of ran around through the northeast side of Greensboro. So I was driving from Davidson County and it told me it was going to take me, where's the little time thing? 32 minutes. But then when I had my iPhone, it said 36 minutes because the highway still didn't exist on my iPhone roads versus the Google Earth roads. And I was like this one here because this is up in New Jersey. at the boardwalk in Atlantic City, where a truck follows a GPS onto the Atlantic City boardwalk, where it leaves a trail of damage behind. And I like this one too, where this is a Oregon trucker, and it went missing because it followed its GPS that sent him up the wrong road, and he had to walk 36 miles out this is rural northeast Oregon, out in kind of the mountains, far from Portland and all that. And so, to me, I think it's kind of interesting because I think with these maps and us following these things, I think we've lost our sense of direction. This is a funny story. My son, his in-laws, this is a really funny story. His in-laws, they went to a wedding. When was he here? Last weekend. So we went to a wedding last weekend of his brother, so his wife's brother, and it was a town called Cleveland, Tennessee. So the parents typed in the word Cleveland, hit go, and guess where they went? They started going to Cleveland, Ohio. And they got to like West Virginia somewhere, and we're like, this isn't the right direction. So they had to like turn around, because to get there, you got to go up through Virginia and then down, because Route 40 is shut down. Route 40 is shut down west of Asheville, going into Tennessee. So you still got to go up, but instead of kind of going back down 81 through Knoxville, they just took a little right on 77 and they're going to Charleston, West Virginia, straight up to, next stop Cleveland. And no adult sat there, these people are older than me. No adult was like, hey, Charleston, West Virginia isn't anywhere near. This is right outside of Chattanooga. Like, we're going in opposite directions. They turned around, and you got to see them fight and blame each other, and because grown adults still fight like little children. So that was kind of funny. Some of the things. Horizontal accuracy, this is Spalding Elementary. So when we download, and some of the things we're working with Erica is a GIS data layer of all the schools in the state. This is a GIS data layer, Spalding Elementary, X marks the spot. This is over where I kind of work out in the morning. This is my kids' high school. This is the high school up here. This is the middle school. So if I were to look at all sex offenders within half a mile of the school, it's really not that, but it's the GIS representation of the school. Now, what could I do in real life? I can edit these data layers. Remember, we created new outlines. I can just set up an edit mode and just say, what? I'm just going to literally move this thing right here. Now, there's 2,500 schools in the state, so that GIS data layer would take a long time to update because they probably just went and geocoded it or used the X, Y, latitude, and longitude of these. Other things are, and I think I've shown these before, this is my data parcel here. This is my parcel where I live. And you can see I own my neighbor's driveway. No, I don't. What's off? The imagery or the GIS data layer? Probably both, combination of both right there. Because a lot of times we think the imagery is authoritative, but to me, it's just still just as bad or good or not good as the other things there. And so these aren't survey grade. Other things with temporal accuracy, how good is it? And so we refer to metadata in terms of how old is it? Look at the metadata. How old is it? One of the interesting things here is this is what we call a DRG, digital raster graphic of this quad, Topo Quad. Back when I went to school, we used to read these maps, have these maps that rolled out, and they were called 1/8 of a degree by 1/8 of a degree. So about 7 miles by 8 miles or so. And this is NCCU. You can see the circle right there. And what's sitting right here? Hillside High School. Where's Hillside High School now? Yeah, there's a whole map. Well, this is the current map that we've got, but it's old. And now you can see there's a church here where Latham was. And then there used to be a church right here on the other side of campus, and they picked it up and moved it like right over there in like 2012, 2013. I was here when they picked it up and moved it. And then over across campus, you can see this is the new student center. They used to have like 3 little buildings right here. going down, I think this is George Street. And then some of the things that are applicable are the idea that some of our food desert research, when we use it, we use NAICS codes, we use something called Info USA, which is just a database that people pay a lot of money for as stores. And I say, all right, let me find all the grocery stores, and this is one of the grocery stores in the database. It's obviously not open, but if I were to just do in situ or analysis on it without looking at anything else, you would see that people who live next door to this are really food needy, when in reality, if I were to do the analysis for this, they wouldn't say they're food needy. And even looking at something like this really look like a grocery. It looks like a glorified house where they sell stuff there. So I thought that was kind of neat. A couple other things like attribute accuracy. If I click on this field, is this really Ohio Ridge Road? Like, is it speed limit 30 or is it speed limit 300? So we're going to really look at tiny Python solutions today. And I'm going to give you the solution. I'm going to kind of let you play with it a little bit for homework to, how do we slickly do this? How do we more elegantly do this? And so some other things here for this Piggly Wiggly. I don't know, you guys ever hear of Piggly Wiggly?
Yeah.
Yes, there's a store in North Carolina called Piggly Wiggly. Have you heard of it, Chima?
There's one here.
No. There's some out west. This one's in Wilson, but there's a store called Piggly Wiggly. Yes.
Price.
What's that?
Big price.
Yeah.
So that.
Yep. But there's a store here called, is this really a Piggly Wiggly? Is it still open? Should it be here? And so this is some of the data, what we call Info USA. It's migrated to something called Data Axle. I guess someone else bought it. And just making sure that all of this information is correct, because I'm not going to make sure it's correct. This is why we have grad students. And then the last thing I'll talk about here before I get into my project is the idea of precision. Meaning how it could still be inaccurate, but how much do we want to measure it? Are we just going to round it up? Like your GPA, we just going to round your 3.4 down to a 3? Oh, no. We want to keep as many decimals as possible. Same thing with minutes here. I got 5.16. Do I want to round it to 5? Oh, let's keep it here. So when I run my regression and my two-tailed t-tests and all these other things, because when I look at something like this, I only have 7 or 8 different values. Here, I've got 20 different values or whatever I have here. So some of the things that people do in ArcGIS Pro is that when we do calculations like percentages, they take and add new columns. The default for adding new columns is a long or a single. What's long? Not single. What's it called? A long or a short or a long? What's a short? Integer. Long. Integer. What's an integer? What doesn't an integer have? Decimal points. So when you're doing percentages or GPAs or anything like that, this computer's dumb. It's going to say, all right, you told me integer. Let me get rid of this and this and this and this, instead of storing it as a float or a double. So those are some attention to detail things that people kind of lose out on from time to time. And then some of the data that we looked at the beginning of the semester was, these are our stations, 35.33 degrees latitude, negative 82.45 degrees longitude. That's the best. You're within a mile of that station. Okay, we don't have very good precision here, about 0.7 miles here of that precision here. And the last example here, we're not rounding GPAs, so that's a bad idea. So for a little bit, I'm going to talk about this project. It's got some sentimental value to me too, so I'll talk about that. But we did this project on how to measure data quality. And Glenn was a former graduate student. I'll talk about Glenn in a second. He was an older gentleman, so we'll talk about some of the issues that he ran into with the project selection. Okay, and really as a forewarning for something. But this project we talked about is that GIS has lots of arcs, lots of characteristics. And now we're looking at like 400,000, we're looking at 1.7 million, 1.12, 1.17 million arcs. So whenever a road attribute changes, we've got to change. Whenever Route 40 goes from 3 lanes to 4 lanes, different speed limit, we get a brand new arc. We got about 1.17 million of these arcs. So you can see these arcs that make up a single route. And so some of the thing about this GIS data, like you saw, is that it's got spatial information, it's got attribute information, it's been collected by various personnel over the last 30 years, and the current state of data quality was unknown. And so some of the issues we have is potential liability. Issues exist with the publication of low quality data because you don't want to get sued for data that you publish that people are going to assume that you own. And there really hasn't been a quantitative assessment done on this. So little research or uniform methods to evaluate dimensions of data quality have really fit the needs for the NCDOT. And so one of the things that I did was in 2013, 2012, the NCDOT has a research grant program. I've gotten probably 4 or 5 of these and have been really lucky. But the one big problem about jobs, when you apply for your first job, what do they always say? If they turn you down, what do they say? Why didn't you get it? Didn't have enough experience. You don't have any experience. And you're like, well, how do I get experience if you don't give it to me? The same thing with grants. Like, hey, I know you want all this money, but guess what? You don't have any prior research, so we're not going to give it to you because we're going to give it to someone else who already has prior research. And so you go through this kind of vicious cycle of, submitting grants, submitting even papers from time to time, and people not liking it because you don't have any, prior research. And so this grant was my first big grant. It was like $76,000, which is pretty good. These days our NASA grant that's coming in is like 1.4 million. We've got another one with the NSF, 1.1 million. Dr. V's running one through something called LitGeo, 2.1 million. That's a lot of stuff. Now, a lot of it goes to universities and salaries and all that other good stuff, but they gave me $76,000 to do this project. I'm really eternally grateful because the next grant I applied for, hey, I got this grant on data quality. And hey, John, the guy's name was John. Contact John and Sean and Tim and all these other guys on the grant to tell you how great a job I did. And I put the report in here because we looked at the dimensions of data quality. What are they? Horizontal. And so when we look at these arcs, how well does it compare to the imagery? Now, for them, when we work with the DOT, they said compare it to the imagery. I don't care if the imagery is off, you compare it to the imagery. Imagery is going to be the authoritative source on these. So we had to see how far off it was. Right? Am I going to do that for every single arc? Of course not. Other things that we've got. Okay. And this is an example of arc versus the center line. These are at the center lines of these. And in interstate highways, you'll have 2 center lines because typically you're going to have a median between those, so it gets problematic. Other things we have are attribute accuracy, meaning how many turn lanes are there? Do you have continuous turn lanes? And so you can look at some of how many lanes do we have? We have 3 different lanes. A left turn lane can only have 1 of 5 possible entries. So if I have a left turn lane right here, these are the 5 possible entries. So at some point in time, I had to go learn all these. I don't really know them too much because it's been about 12 years. And so they want to look at some of those attributes for these arcs. And they had about 93 different attributes here that need to be looked at. So we had things like street names, the location of the county, what is the median width, what's the median type. This is the national highway system type. What are the number of lanes? We had to go and kind of check all these. Now this was for what we call data quality. Is it actually correct? And so there's both a spatial component and an attribute component as well. And we also wanted to look at something called data completeness. And so we came up with all these rules, meaning I forget what RW means, but trading, turn lane right type CD. It could be 0, 1, 2, 3, 4, 5. These are the only spots, so it can't have a 27, can't have a yes, you know. And so we had to make sure all of these were, you know, the shoulder type. What are the different shoulder types that it can have? The kind of a little area off the road right there. So those were really neat. In addition, we looked at things like attribute completeness errors, meaning if you have a median width, then you better have a median type. Okay, so if you didn't have a median, like the area in between a road, it better have a width and it better have a type. If you have a left turn lane and it's not null, then it better have that left turn lane better have a width. So all of these co-population attributes. Now, can you think of ways you could do, you know, and I think you see Daniel's kind of stuff turning his head there, like, yeah, this is pretty easy to do. I got this column and this column. And believe it or not, I did all this stuff in Python. Many of you wouldn't believe that right now, but I did. And then they also want to look at attribute completeness. Hey, are things filled out now? I don't care if they're right, because we're not going to check all 1.2 million of these. So I did some sampling on all these here. This was our research team. That's me, of course. I think some of you met in the upper left. That's Roderick, and he came here for GISD. He works for the NCDOT. That's Glenn. That was his son Corey who worked with us, and then this is Edward who works for a contractor. Glenn, he was a master's student, kind of second, third career student who came to us from Elizabeth City State. Did all of his work, got all 30 credits done, and he left because he couldn't do a thesis. Didn't do a thesis. Now, why? You know what the topic of his thesis was? He wanted to figure out, solve the water crisis in Africa by building a inland ocean in like Morocco. And I was like, yeah, I said the same thing. I'm like, that's a lot. You know, doing the DEM, and now he wanted to get all these DEMs for Morocco and build like this canal, and like this, how big was the lake gonna be, and how deep was it gonna be, and then he got with a faculty member and other things, and maybe Dr. McGinn talks about this. In your department, you should know, who do you work with, who do you not work with. And he went straight to our modeler, who is, don't work with him. You know, well, I want this to be hard. And he worked for a year and another year, and you know, his advisor, who's no longer here, wasn't going to budge. Like, hey, you want to do this? Let's calculate the volume of water from the Atlantic Ocean that you're going to build in this lake in like Western Sahara, and like, oh, it's just ridiculous. Like, yeah, I know what you're thinking. You know, and he worked with me. So at the time I should have been like, no, you're going to work with me. You're going to turn this into a thesis. But I was a new faculty member at this time. I was just like, no, this is going to be your thesis. And he's like, no, I want to do Africa. I want to solve the water problem in Africa. Okay. What's that?
Thesis.
It's for a thesis. Yes. Not for a Nobel Prize, or just for a thesis at North Carolina Central University. It was so ridiculous. And so, yes, he wanted to build a canal from the Atlantic Ocean and throw in desalination plants in this big inland sea. Yes, I can't even wrap my, like, because Chris McGinn had just come. Ask McGinn about it, and like what the sea level was going to change. And these advisors here, and I hate to, you know, joke about it, but these advisors, the guy was like, you know, the advisor like, yeah, sure, go do that. And he'd come back, well, you're not done yet. You're not done yet. You're not done yet. You're not done yet. And finally, he's like, I don't know what to tell you. I'm out of here. You know, and he was here like an extra year doing stuff. Yeah, I'm not done yet. And so a lot of times we deal with folks here like, don't save the world. I've got a couple students I've got to kind of rein back here. Like, let's just do things that we can do. So like here, you know, stuff that Erica's doing. Hey, let's just do Durham County, surrounding counties, EOG scores versus attendance. That's it. You can go save the world when someone's paying you $90,000 a year. go do that then. For us here, get out. And also, I'm sure there's some things in this department where, hey, if you want to work with Mulrooney, he'll do this. You want to work with McGinn, you'll do this. You want to work with Dr. Bang, hey, you're gonna have to put some time in the lab. Now, if you want to put time in the lab, go ahead and do it. But if you don't want to put time in the lab, 3 days a week, then don't, and so be careful, hopefully talk to each other, because there's a whole nother component to that. Because me, I just weigh it. If it weighs enough, it's good. Now, me, I look at the maps, I look at the data. Hey, you better have sound data, sound processing, and you're gonna have to go and, revisit. So that was Glenn, really nice fellow. I don't know what happened to him, but he can always come back and just do a master, move to a master's project and get out. And the faculty member ended up leaving for another position. So it was like, he was gonna have to start all over again. I was just, so don't think too big, So what we did, sampling methods. We used the word sampling methods, right? Because we're not going to check all 400,000. We're not going to check all 1.7 million or whatever. So we just took about 11,000. So these folks, these students went and checked about 11,000. They do, 60, 70, 100 a day, run some Python. And in the background, what I did was I ran all the Python to process what they were doing. So I was really a good Python programmer back in the day. So the last thing we did, what we did to measure horizontal accuracy was they had to go put points where the road really is. So I created a random sample of points. Okay, a random sample of arcs that they were going to check. So from this county, you're going to pick 80. From this county, you're going to pick 100. From this county, you're going to pick 120 based on how many arcs were in each county. And then what I did was I went and wrote a little Python code that had the arcs versus the distance. And then all I did was I automated it, just measure this distance. So I wrote this little ArcPy, that near analysis. What's near analysis mean? What's the near function? Anyone remember that from 4010? Yeah, find the distance. How far is it to the nearest neighbor there? And so I calculated this right there. Look what I did there. I ran a statistics analysis. All I did was what? This is a summarize into an output table using the near distance. And then all I did was write it to some database that I concatenated with the county name. And so it's pretty slick, isn't it? Daniel's pretty impressed, isn't he? Was that? It's pretty cool. I did this. I did this. Pretty slick. Because, yeah, so, and then I had a CSV file of all the county names. And so one of the neat things was I just went through all the folders because I listed all the counties, and the name of each database was a concatenation of the county name.gdb with the county name underscore like LRS. So I would just go and auto-generated based on a big list of all 100 county names. So we go Alamance first. It's going to create an Alamance GDB with an Alamance LRS. And I'm going to write it right into the Alamance LRS. When I'm done, what am I going to do? I'm going to go to the next county, Avery. And then go all the way through. So I'm auto-generated geodatabases. I see Daniel's still nodding. He's still impressed. Is Shima impressed a little bit? Okay, good. I could not do this now, but this is kind of, I did all the back end programming because they were just going and doing the measurements, checking if it's correct. And then I ran all the Python to put all the stuff together because these folks aren't going to want to watch this. Also with the attribute accuracy, with the random samples, I asked them to go check, hey, just check, make sure, does it have a turn lane? Yes or no? Is the turn lane, how wide is it? Does it have a median? Yes or no? Because a lot of these are not going to be popular. Some random road here isn't going to have a median. It's not going to, it'll probably have a shoulder, might not have a shoulder width. So I had them go check the horizontal. I had them check the attributes to make sure they are correct. And then basically what I did was the attribute completeness. I did it for everything. I did the same exact process because now that could be that could be Pythonized, for lack of a better term. Like, hey, is turn width populated? Yes or no? Does it have a value of 0, 1, 2, 3, 4, 5, or null? Yes or no? If it's null, then I don't have to check to see if it's got a width. I'll just go to the next one and run all these checks. And then while I was doing it, I put all the errors in a big error log for all whatever, 700,000 LRS arcs. How big do you think that error log got to be? It got big, like 1.7 million. And so I said, DOT, look, here's all your errors, go correct them. But I'll show you the final, some of the final results here. So some of the results here were that I made maps of horizontal accuracy where this is a map county by county where the data was the worst versus the data was the best. How far the actual maps deviated from the imagery. And the interesting thing is that like some of these are still spatially related. That's what I find is most interesting. Now, why do you think they're spatially related? I think, NCDOT divisions probably get different funding. I'm sure the people who live out here are worried about deer vehicle collisions. They probably don't care about the quality of the data, where that around Wake County, they probably have like a couple of GIS analysts that work for the NCDOT division itself. I can see Buncombe County here. That's great. That has really low accuracy. All right, that's Asheville. Probably the city of Asheville might have a GIS analyst that had to do their E911 or something like that. So they had to make that type, while the surrounding counties are still county GIS data managers that are uploading this data that they don't really care, or it's not a priority because they've got other things to worry about. So I thought this was really neat. We made some maps. I'll show you lots of other maps. I'll show you the final Excel spreadsheet that I got from all this Python programming, because they don't want to look at this stuff. And so the results from the attribute accuracy, how well the attributes. So we had attributes like Avery County, only 76, about 3/4 of the attributes were correct. So when it said turn lane was correct, oh, no, it wasn't correct. It said this was the turn lane, but I can obviously see it's a continuous turn lane, and you didn't have a width because there's a turn lane there. So you got both of those wrong that are incorrect. And so I went through it. As you can imagine, I ran through Python and just ran all these statistics that these students have put together. Now, this is a little more kind of haphazard here with the attribute accuracy here. But those 93 attributes, and I think they focused on about 20 or 30 high priority attributes like road name. Is that road name correct? Go look at a third-party source, or another party's source. Is the turn lane correct? Is the medium width correct? Does it have a number there? And so I used Python to kind of go and run all these things here. For this attribute, this attribute here, National Highway Service type, 97% of those, the average is 97%. Bunch of counties had one. So you can see all the different types of attributes. So I broke these down by county. I broke these down by attribute. I would love to go and take a lot of money to redo something like this for state of North Carolina or whatever, because these were really neat tools. This is really comprehensive. In addition, we looked at things like, what are the criteria? Is it correct? Which counties were the best? Which counties were the worst? Lots of neat things here. And as you can imagine, when these students create all these things, just like these days with our, Instagram and our Facebook, what is user engagement? How long are people looking at these things? Tons and tons of things that we can look at. So dependency scores, attribute and dependency completeness. Meaning, are these actual correct? Is there a null here when there shouldn't be a null? And then the dependency means like, if you had a turn lane, you better have a turn lane width. And so there was probably about 15 different rules attached to those. And so I just created and generated these giant, maps, and then I weighted these scores here. So I kind of went and averaged all of these up for each attribute for horizontal accuracy, attribute completeness, and went from highest to lowest, where Craven had a really low score, and 0 Forest, Yes, and so I created a scoring system so you can see what the best data was and the worst data, you pretty neat. And I made some recommendations here. We'll work on those here. Future project ideas, but you always kind of give credit to the people who give you the bucks here, but this is about a $76,000 project. But what I created, because I could bore you. I could bore you with some of the Python code here. Because this is the project report here. So you can see some of the Python I generated here. It's hard to believe I did all this, but I really did. But I put together all these statistics. I posted this to Canvas. So this is in Canvas here. Some of these are kind of brute, brute force where all right, I'm working off of, the T drive, working off the T drive, NCDOT Mulrooney, so I'm not bringing in like folder locations and all that other good stuff. But at the end of the day, what we got was these reports here. And so I ran all this Python, and so I got attribute accuracy reports right there in one. I got horizontal accuracy, attribute accuracy for all the different fields that they looked at. Do you think I'm typing this stuff in? No. Python's just doing this for me nicely and neatly, and I'm just cutting and pasting from the results right into here. Attribute completeness, final scores. I think I broke these down by urban and rural as well. So urban areas versus rural areas. So, look, how long do you think it would have taken someone to do this? Now, the students spent the summer, hey, I'm going to put points here, points here, points here. Hey, is this correct here? But I spent the whole summer just putting together this. Hey, do your stuff. Let me go through the T drive, which was shared at the time, and run this. But now we can access these through the cloud. Pretty neat stuff. All right, let's take about 10 minutes here. We'll start at 6:20. I'll talk for about 40 minutes about some Python programming, and then we'll call it the day and look at the exercise. We'll take a quick break here. I get excited about talking about all my projects. So.
Professor Maroney, you still there?
No, he just stepped out.
Okay, I'll get him after class. Thank you.
Yeah. So. Okay, yeah. So let's start. Journalism.
I might need to much more information, but I know what you do is you just, that first block, 11. What you do is you select, it might still need to be, so. Final additions to the steps, but like, person would, you don't want 2 or 3 parts. In your case, 12 parts. You pass it. Then once you run it, it just brings you to the process from start to finish. And I'm sure you should be able to also try code to change the.
Yeah.
So. But I hear you also.
Yeah.
We can do it. Yeah, sure, because, so I'm free, I'm keeping you. Go ahead, test tomorrow.
Oh, yeah, yeah.
But
What this should do. Yeah.
even I need to get stuff down. Something for. Especially just that kind of body. There, so, there's some actual research on. Wants to make a different direction and see instead. Yeah. Sometimes he might. You know, like you said, inherit stuff like. What's in it? This was my like patterns that I would observe. Travel. For the region, so they compare it. Yeah, so this stuff would actually come in. So to do this process as an individual. So yeah, it would be like a view process for me to kind of learn what the whole breed. Yeah, exactly. So,
But that's great, and not just wasting your time. Yeah, the other thing I said, the only other thing I started to look at, like, I think that might be enough if I can just get the change the input, like you said, change the input, sort of parameters, see if it's from the font, and that's what it is.
yes.
That might be enough. The other thing I was going to do is change the symbology. And I looked to see if there's a way, I just did a quick Google chat or change the input. Already it said there's a way to do it.
You mean the symbology?
Yeah.
Yeah, there's also arcade. So arcade, you either use arcade or you use a JavaScript. So it gives you access to the map features and feature layer modules and libraries that you get like kind of like so say for example change or yeah, then you can apply this change.
That's what I was hoping. I was hoping we could put all in the model.
So these symbology that you want to change is in on the
I guess either way, it would, as long as it ends up in the output, as long as that's
okay.
be either one, but there's like what, two of that, I'm not changing anything. This is like, if you go to the map. This is, it's like I'm looking at core of the map. This is what it looks like here. And so, biggest knowledge.
You can use
Yeah, I was choosing like this. I was thinking. Oh, I know. Instead of standard deviation. And then that gave me. Yeah, that way, you can see the different values, that's what I was doing. So then I was thinking, oh, it'd be nice if I could automate that, so I was like, okay, how do I get it to change the color scheme and change the stretch type to standard deviation
For every single,
for all 12 of them.
they should be able to do that. But you can get that like on arcade, because I know Esri tries to push arcade, because it's more in-house, it's like it was built by Esri. So
Okay.
kind of like managed there. Yeah, so
Is
I could check.
arcade the same for Arc 5?
It can be Python, it has this like Python syntax, but there are slight changes, like slight, yeah, slight.
Okay. But then, if you have time, something sort of take.
Oh, but I'm more like more into like once.
Oh, I got.
But I mean, I can do early evening. So, like, 7 to 8.
Yeah, yeah. That's the one thing, yeah, I just, usually my Wednesday's not bad. Yeah, I have this all day conference at work. Not like mandatory, but my boss is like, yeah, you should do this.
You can tell it doesn't suit bad.
Yeah, yeah, Thursday, I could do Thursday. So,
Oh, and so it's,
oh, like 8 o'clock? Yeah, how would I have 9:15? Oh, that's the meeting for this project, yeah, so it'd be good to do it before that, but if when.
yeah.
This thing will be over by like 5, so I can do it by 5. So,
Works.
okay, thanks so much. Certification.
Almost 6:20 here. Okay, so what we're gonna do is we're gonna open up exercise number 8, so we'll take a minute or two. Got any, Chima's here, if you got any help, if you need any help here. And, 'cause I'm gonna drive for a little bit here. And I wanna open up the Canvas. because people joining online, I just want to make sure you know. We're just kind of following the process, because even now I still have some folks who, you know, I still have some folks. Still have some folks who are having trouble unzipping. So if you don't do it all the time, it gets, you sometimes forget. So, okay, so we got modules. And we are gonna go down to week number 9. And then this is week number 9 exercise. We got exercise 8, because remember that week we did R. And so we only got 2 weeks after this. We got metadata, and then we got machine learning. And machine learning I'm kind of excited about, because I just kind of started doing it and I've got some really neat ideas for it. So, all right, so we're going to download week number 9 materials. It's 314. That's not that big. All right, you can see it's downloading up here in my upper corner. I'm on Wi-Fi here, so I don't have a direct connection or plugin. Do you need to, do you want me to log in with using mine? Okay, let me log in using mine. I don't want to make, I want to make sure we're all kind of. All right, and one of the things is make sure you unzip it, because when you see the zip file, this says extract all. This doesn't say extract all. So when I start rooting around in here, these are just all the files sitting within the zip file. And the zip file is just a compressed file. All it is just a compressed file. Okay, so now I'm here. All right, first thing is managing data quality using ArcGIS Data Reviewer. This ArcGIS Data Reviewer was just coming out back when I was getting into GIS migrating. All right, so Data Reviewer. The next thing we're going to do is we've added a couple new commands called update cursor, cursor.update row, and search cursor. What's a cursor basically? It's a little pointer. Now, in Python, cursor is basically a cell. What's a cell in Excel? The little square where it's located. And so this cursor goes from one to the next, to the next, to the next, because typically what do? In Excel or in attributes, hey, we look for a particular attribute, we just keep going down using our row commands or fields command or our gigantic loop here. So I can go what I originally did was I went to the NCDOT, and some of the things that we've done with the NCDOT is that I can download municipal data layers, county boundaries with shoreline, NCDOT divisions, road characteristics. This is a big PDF that describes all of those road characteristics that I got to learn about in that grant. You can see where are we at? 91, 92, we're at 95 different attributes now. So they've added a couple attributes since I've gotten there. And they did remove some attributes here as well. So this is some of the raw downloadable data. Road characteristic arcs, NC arcs. You kind of have to look at these things, but you can see how big these files are. The other thing that I did mention here, I looked at NCDOT, AADT, GIS data. And to me, this is traffic volume maps. These are some of the traffic volume maps here. So we have interactive tools. Now, I hate to tell everyone, but I like downloading the raw data values and just looking at these. But these points that I was talking about, so I can go over here near the NCCU campus. And they've got a couple of these here, so I can click on this point. And they can see in 2003, it got 16,000 people per year. 2023, it got 12,000 people per year. The one over near the new nursing building, we're at 21,000, 26,000, 20,000. And then they stopped keeping track here in 2013. And then 2019, 22, 5, 22, 22. These are traffic readings. So if you want to look at air quality data, probably high scale air quality data. Some of the air quality stuff that we're getting from Air Now, where we have 22 stations across the state, that's what we're looking at, major scaling issues here, you know, looking at major scaling issues. Now, me, I'm the type of person who I want to get the raw GIS data and download those. That's all.
Let me get it out.
No, I got it out.
Cool.
You're share a little bit with you.
Can everyone turn off their volume there? Or I can hear you there, or mute yourself. And then here's the GIS data. So this is the downloadable GIS data that you can look at here. It's where it's here. So this is the shape file. This is the 2023 traffic segment. You can go download these. Shape file. It's about 6 or 7 different files. Make sure it's stored in the same place. You hit the black plus sign, one file shows up. So these are this is kind of my old skill set, but look what they store them as. Nice little zip file because there's about 6 or 7 of them. So now we've got extract all, NCDOT. Look at all these files, and few of these here are the shape file, and then it's got some Excel documents, all this other stuff. But now we can add this straight onto our ArcGIS Pro here. Just for the heck of it, just because I want to show all the stuff I can do while I'm thinking about the Python. We got our folders. There we go. Okay. There we go. Cool. There they are. Here's all your AADT stuff. Average annual daily traffic. So we can download these. Now think about what you could do with these. I can't because you guys got a lot of neat things you can do out there. You know, hey, let's get some purple sensors, see if there's a relationship, you know? So a lot of neat things that we can do with these. All right, let me uncheck these. All right, so let's go back to the homework. So we discussed some Python programmer. We're gonna clean we're gonna clean what we call speed limit. We want to check the data quality because we did see a real world example of where speed limit compromised the results of something. Now, is it a big deal that I'm going to get home, you know, half an hour later? Someone like my wife is just going to say it said 22 minutes. So I just said, you know, without, hey, I'm still in, you know, Virginia. So that doesn't really, you know, matter too much. But one of the things that we're going to do is we're going to update the code for a road characteristics database, and we're going to run an example that I already kind of created. So I've got this in ArcGIS Pro. I've got the highway exits. I've got the road characteristics. Now I've got the road characteristics for the entire state. I didn't want you to have to run on all those. So I created a subset for region 7. So region 7 is over here. This is over where I live. I live like right up here somewhere, one of these roads here. Yes. Yes, I live right over here. So, and this kind of goes from Hillsborough all the way up to Greensboro, Rockingham County. So I created a subset for it. And within this subset in region 7, we're still looking at about 90,000 of these records, 90,000 of these records right here. And these are the road characteristics, basically where the segment of road changes. It could be the same street, segment of road changes. Now, you could look at anything because I spent a whole summer writing Python code to make sure, hey, do we have a route name here? Because I'm not going to sort these and look for the null. I could, that's kind of bush league, to be honest with you. And I kind of cut and pasted all my code in here. So is the route name here? What county is it in? All these other good things. But there is the thing that I think we care about a lot is, you can see here, median width. That's pretty cool. Remember we were talking about median width before. Median type. Hey, if there's a median type, there better be a median width. So those are all the prior checks that I did before. There should be something here, speed limit. Aha. Here's a speed limit right here. So we have some of these that are speed limit 70. I can sort ascending here and I can see speed limit null. Ooh, what are you gonna do if it's speed limit null? What's your phone gonna tell you if it says speed limit null? I don't know what it's gonna do. It's gonna do something weird, right? What's anything divided by null? Null. What's anything times null? Null. Anything plus null? Null. You know. So this stuff better get corrected, especially if this is going to be eventually used as a authoritative data source, whether not by Google or online services, but like planning or whatever.
To the around the person. So if there is a case where like speed limit is null, but indeed use like speed limits in post processing.
Exactly. That's what we're going to do. Exactly. Because that's exactly what we're going to do here. Now, some of the ideas, and I'm going to kind of leave those up to you because I think some people are thinking like, hey, the Python programming solution I created, if it's null, just make it 35. If it's null, make it 35. How do I know it's 35? I just put it in there. But if it's null and like, let's go over to the road type, it's NS or whatever, it's a normal route. Are there other indicators over here that could tell me what the speed limit might be? I don't know.
Like the type of road.
Type of road. And some of the things that we see here, this is non-system, which basically means these are under the jurisdiction of a particular city. So this is probably in the city of Burlington or something like that, because I saw that it was Alamance County. So Burlington County is in charge of these. What is the speed limit inside the city limits of Burlington or Durham, unless otherwise stated? Probably 35. So if you see anything that's null and a non-set that says non-system, what am I going to make the speed limit? 35. And so what I did And then what I did was I created a subset of those because I wanted to get rid of all the nulls. So I just created a subset of those. And I'm going to run it on this, and then we're going to look at the code. So I've got about 46,000. And so when I go over to speed limit and I sort ascending, look what kind of speed limits I have. Like -68. I don't know why, how it got to be -68, but I got a whole bunch of negative values here. Okay, I don't know who put that in there, how it got there, whatever. So you see a lot of these wacky values. What's that going to do to like your time calculation? It's going to like add time, you know, like you're already there.
You got there yesterday.
Yes. So, but you can see these errors in some of this raw data. Now I would imagine Apple and Samsung, all these probably go through these with a fine tooth comb, especially since all their road data is probably just sitting on one server, you know, sitting on a server or whatever. But we got these speed limit -68, you know. So what I could do if I wanted to, I could do select by attributes. Let me look for anything that's less than 0 and do a replace. Now we're not that we can do that, but you're going to do that for the entire state every time it gets published? No. Are you going to go and check the nulls? No. And so I created something here called null checker. I was probably afraid to change the name to it because this isn't null checker anymore. Because remember that null checker we ran a few weeks ago? Hey, let me just go look for all the nulls. So I'm going to right mouse click and click on edit. This looks largely the same right here. This here. Now, what did I do here? This is a really simple program that does what? I took in one parameter. I took in another parameter. What's the first parameter that it takes in? Input layer. What do you think the input layer is going to be? Hey, this LRS ARCS feature class. Cool. What's the second parameter I'm going to take in? The field. What's the field we're probably going to pick? Speed limit. Now in the future, hey, if the field that you picked was this, go and check to make sure it's got value 1, 2, 3, 4, 5. So that's kind of what I did. Now, what I did was I put them all in one big Python, one big thing, and I just said, hey, the field name's speed limit, the field name's this, and if the field is speed limit, you make sure it's over 0, make sure it's complete. If the, if the field name's this, run these checks and write all these to a CSV file while you're doing it. I did some really robust stuff. And so what do I do here? I do with an ArcPy. So my fields are equal to field. And so this is code that we've already had before and that we've already run, but we've already run this code right here where this stuff in blue here, I said arcpy.da data analysis update cursor input layer fields. So those are your input parameters. What's a parameter? Something that it needs in order for it to run. Like f at x equals 2x plus 3. Or in small basic, the square root. It needed a base and it needed a power. If you just put in a base and put in nothing else, it'd say, hey, I need something else. So for this update cursor, it needs a what? Input layer and a field. Now, right now, there's only one field. I could have brought in 5 different fields if I wanted to. But I don't know what 5 fields they're going to be. And for now, we're just going to do it for the speed limit. What I say for in cursor, that means all I'm going to do, and the cursor, all that's going to be is your little cursor cell. So I'm going to start in 4-row in cursor, and all I'm going to do is just keep going down and down and down and down and down. Now this one says if row is none. What's none a fancy word for in Python? None, exactly. I don't know why they call it none. Maybe someone else can answer this for me. I don't know. Okay. So for row, if it's none, we already did this. It says, hey, record number blank is null, and then count null equals count null plus 1. I'm just counting up all the nulls. Now, we're not going to run this because what I did was I originally ran and got rid of all the nulls, right? I got rid of all the nulls in my new database. I can run it again on another feature class that'll calculate the nulls as well. This is all we did with this new code. So if row is not none and row is less than 0, what is it asking for? If it's not null and it's less than 0, what type of numbers can be not null but less than 0?
Negative.
Negative numbers, exactly. It says, hey, record number blank is less than 0. Count LT0 less than 0 plus equals 1. And if it's less than 0, I'm just going to make it 35. And then cursor dot update row. What is cursor dot update row? Update the row that was just added, but it's clicking that save button, right? So whenever you're working in Excel, what do? What I do, I Control S, Control S, Control S, save, save, save. And so I'm going to go, basically, I'm going to start up the top. Is it less than 0? No. Less than 0? No. Less than 0? Yes. I'm going to put a 30, I'm going to print something out, and then I'm going to make it 35, and then I'm going to update it because I'm going to go to the next one. So I got to make sure I save it before I go to the next one. And then while I'm here, I said the total count I have is the total number of records, but I can get that another way. That's okay. The total number of nulls is something, and the total number of less than zeros or something. So while I'm there, I'm counting all these. Now, the one thing that I'm thinking of here, why did I make it 35? I was too lazy to do some sort of check because basically for homework, what you're going to do is, hey, just find, maybe think of some elegant or other slick way to see if it's a different value, hey, let me look at this other field to do that. Okay, now you might have to play with the fields up there, like, hey, fields equals field 1, comma, highway type. And, okay, so bring in these fields and then look for this second one here. Tricky. Manual here. So look at, hey, it doesn't have to be 35. Let's look at some other fields. So we might need to bring in other fields there. Now, give me half an hour. I'd have this looking pretty slick, but we all want to get home. So yeah, I gotta be up early. All right, so let me run this. Okay, so what we're going to do basically is play right here this week with these. Play right here. Okay, play right here. Okay. Now I'm going to run it the first time here. So I've got 46,000 of these here. I've got some negative speed limits all the way up to 70. And I just created a subset, which were my non-null values, right here. And so you can see like my inner city, especially over near Greensboro, it's doesn't have anything there because it doesn't have the speed limit there because it's not within this LRS ARC system. So I'm going to click my null value checker. My feature class is going to be what? All right, this test for data science class because I created this before class. And now what's my field? Well, I'm going to just go down and pick everything. Now, back in the day, hey, I picked a bunch of fields, or I could pick multiple fields because we've brought in multiple fields already, right? Haven't we gone and created multiple fields, multiple feature classes or whatever? Okay, I'm going to do speed limit. I'm going to run it. I'm going to just X out of this. And I'm just going to run it. Hopefully it runs. Oh, wow. I ran it. I got 1,102 messages. Let's see these 1,102 messages. View details. Okay. Record number 46 is less than 0. Let me go down. Yeah. So what did I get? 46,000. Null count is 0. It's a null count because I got rid of all the nulls to create this subset. And then I got 1,098 less than zeros. How's that sound? All right, let's make sure it worked, right? Open it up. 46,000, where's my speed limits here? Speed limit, sort of ascending. Where'd the negative 68s go?
They become 35.
Exactly, I mean, 35s. So I got a lot more 35s. And I can right mouse click and do some, I could do a before and after and do a summarize on these. So, hey, look at it. If I run a summarize, I increase the number of these by, I increase the number of these by a certain amount here. Right? I'm going to run it again here. Instead, I'm going to run it on the region 7. Let me just run it on the whole road's characteristics. How's that sound? Speed limit. I'm going to run it on this entire thing and see what it does. It might crash, so we'll see. Oh, it doesn't. Oh, what's that mean?
Close the attribute table.
Yeah. Close the attribute table. Let's try it again. You think that's going to be it? Okay, I guess it is. Thank you. Yeah, I've got a lock on there. And those are some weird things where, if you've got two ArcGIS Pros running and they open up the same project and you try to run a Python on it, it's not going to like it because it's open somewhere else. So look at here. I'm at already like 606,000 messages here. And what I'm also doing here is looking for the nulls, looking for the less than zeros. So I might be here a little while here, but I ran it on the entire database here. And this is real slick. Now, in the interim, like, hey, if it's null, let me just make it a 35 because it's probably going to be what? A non-system. It's going to be a Greensboro or Asheville or Durham or whatever, something within the city under the auspices or jurisdictions of someone else. And then maybe if it's negative, hey, I better go do some checks. Now how many checks do you want to do? Are you going to make this your life's work? Are you going to be building inland seas in Northwest Africa or Northwest Africa? No, you're not. You're going to, hey, let me check this field. If it's class number interstate, make it a 65. Well, there's some interstates that are, I don't care, just make it 65. If it's a US highway, make it a 50. If it's a local road, make it a, 35 or whatever. And those are some of the challenges that I think a lot of people run into, being too good. Be too good when you're making more money than me, Don't be too good now. You got the idea of it. Let's go with there. So let's look at these details here. And I've got 606,000 records. I always print out my little test at the top, and then I go all the way to the bottom. Oh, yuck. I can't even do this. Okay. Yeah, I got a null, I got a less than zero. So I've got 28,280 of them that are less than zero. I got 117,000 records, just less than a half are null. And then these are less than zero. At the same time, I was going through and replacing these less than zeros with 35. And at the same time, I probably could have done the same exact thing with null by just copying that code up there that said, hey, if it's null, while you're there, count the number of nulls. And while you're counting the number of nulls, replace the record, because it can't be null and less than zero at the same time, right? Because they're mutually exclusive. Okay, it's got to be one or the other.
Yeah.
And I already set up a conditional that said if it's not null and less than zero. So we did this here. And so the main thing with the code here is right here. So I could just, if I really wanted to, row sub zero, move it up here, make all the nulls 35 or 40 or whatever you wanted to, and create a nice little check right there based on something else. Now, if I wanted to, now I look at these road characteristics databases right here. There we have it. I can go over to speed limit, And I bet you every non-null speed limit is going to be greater than 0. So I can run a summarize on those, but you notice I was able to run summarize in Python. Now it'll take me an hour to figure out how to do it again. Last couple things I'll mention. There's some other slicker ways to do this. At one point in time when I was doing this, I wrote all the errors and everything, not to a text, or not to this output, output details. I wrote them to a separate CSV file. So we can read and write to CSV files. And I'm not sure if anyone did this in Small Basic, but you can write to CSV files. What's the C stand for in CSV? Comma. So it puts a little comma right there, or you could actually write the comma as well. I also had a student write error files to HTML files. They created blank files and then they auto-generated HTML. What's HTML? Hypertext Markup Language. That's just the language of web pages. So they created little tags and said, hey, if this is a bad error, make it in red, change the text to red. If it's a medium error, make it orange. If it's good, make it green. Because we know what red, orange, green means, right? We drive every day. So I'll show a couple things here and then we'll call it the day, look at the homework and really just play with that Python code a little bit. To me, these are really little Python snippets that you can build into theses, a thesis project, a master's project, a whole thesis that you can build on. Hey, I'm doing a project that checks on the integrity of NCDOT ARCS data. You just started with one little attribute, pick out a whole bunch of attributes, see how messed up it is, and give me a report on it. And it'll take you maybe 40 or 50 lines of Python code starting from this. But let me real quick look at let me see if I've got any of these Python files available, and then we'll call it the day, if that's okay, because we still got another hour. Oh, yeah. Oh, wow. Okay. This is what I did. Whenever we ran into an error, we wrote these to an error log. And so these are all the county name error logs. But every error that I ran into, I wrote it to a CSV file. It is too large. And you see what happens here? So when I went through this county, each of these have a segment number. It's got an error. And so you can see the error that I wrote to it. And all the errors. So when I looked at the attribute completeness, I think these are just attribute completeness errors saying, hey, all improvement fields are not co-populated. These are not co-populated. I need an improvement field, but while something else was being this needed to be populated with something else. Right? This, whatever this is, must be positive and cannot be null. So these are all the errors that
You pulled the errors from objects.
No, I pulled these from the attribute table, and then I created a little, like, might have done a little lookup table, but I had a whole list of error numbers.
Right.
And then I just said, hey, if it's error number 41, write this. If it's error number 42, it's error number 43. So we agreed on a list of error numbers with data completeness.
Right.
Is Daniel impressed or no?
Wait, so.
You just say yes first.
Yes.
Yes, okay, good. That's all I want to hear. Okay.
The error, describe all the errors.
Yes, yes, we described all the possible completeness errors. And there were probably about 25 of them that were just, hey, these lower ones, like, right, this needs to be a positive value and cannot be null. Like, and we sat down with the DOT, like, hey, we want these, but the higher ones, like, 42, this thing has a legal value and has not occurred, like these two need to be co-populated with each other. So some of those dependency variables we have. Are you getting any ideas for grants or something along this? Yeah, thank you. Like, and the thing about grants is, it's all great, my last tirade, but it's all great that you think it's cool, but you need to convince someone else that you think it's cool. And someone else with money who's willing to pay for it, who's gonna see utility in it out there. And so this was, $80,000. Now, looking back on it, I probably could have charged a lot more, done some more student work, thrown my money my way and all that other good stuff. And probably had this for 2 years, but we came up with a big list of errors, errors that said, all right, speed limit needs to be populated. And there might be some speed limit ones here, but look how big this file is. We're at 108,000. We're still at Wake County, and this is where Excel says no mas. Anyone know Roberto Duran? Big boxing fight. Remember that? Remember the no mas fight against Sugar Ray Leonard, I think it was? No mas. So this is where Excel says no mas, right there. And so how many more counties are there after Wake? I probably could have written this to a TXT file, a text file, or just wrote it to a TXT file and brought it into R. That would have worked, right? Actually, I could probably bring this straight into R, this whole file into R, because this is just Excel opening up the CSV file. R can open up that CSV file just as well and probably give me a few more records. How many more counties are after Wake? Probably Wake, Yancey, Union County, and that's about it. Or my alphabet's a little off.
Yeah.
W, X, Y.
Yeah.
Yeah, I was just seeing if everyone was awake, so I'm just making sure. Okay.
Yancey built that.
Yeah, so Yancey. So this is pretty slick. I really like this project. As you notice, my Python programming skills have really deteriorated in the 10, 11 years that I've done this, but these are pretty slick solutions. Well, I think of it, there's some really neat, like Eisenhower scholarships out there, Eisenhower Interstate Highway System scholarships out there, graduate, NCDOT, USDA, Federal Highway Authority, they might have some value in these or whatever, but I don't want to keep everyone here forever. So exercise number 8, we use the update cursor, build on that with your if statements, look at other fields. Also just keep that original file, because if you go and mess something up and you can't go back, it's like, keep the original file, copy it. And then just create some new code here. Create some new code, add what you want. Clean the data. I literally just cleaned 1.7 million records, right? Like, think about how long it would take to go through and look at that stuff for just one field. Like, hey, if it's less than 0, make it 35. If it's null, make it 35. Just make sure, hey, make sure the interstates are all more than 55. Like, those are all some things that you can do just like that. And it took me, a minute and 22 seconds to clean an entire field of 1.7 million records. And so if someone like me can do this, someone like you who do this for a living, get paid lots of money to do this, can do some really slick things, really powerful things, and impress people. Because your boss, who makes more than me, probably, they haven't done this stuff in 15 years, just like me with this stuff. So I'll quit wasting everyone's time. We got the homework. Play with this code a little bit, look at the data reviewer, and kind of next week we'll look at metadata. So everyone have a great day, and we'll see you all later. All set, everyone?
Okay, Mr. Moran.
Yes.
Thanks.